Hi students, this is Alex here. In this video, we are going to expand in Fourier series of the given function f of x, which is x sin x, for 0 less than x less than 2 pi, and we are going to deduce this given result. Now, we are going to write the Fourier series expansion formula. F of x is a0 by 2 plus sigma n equal to 1 to infinity an cos nx plus sigma n equal to 1 to infinity bn sin nx. Now formula for a naught is 1 by pi integral 0 to 2 pi f of x dx. And now this is 1 by pi integral 0 to 2 pi x sin x dx. We are going to use Bernoulli's formula to integrate this. So this is u and this is v. The formula is, when we have u v dx, it is u v1 minus u dash v2 plus u double dash v3 and so on. So from u we can find u dash, which is 1, u double dash, which is 0. From v we can find v1 and we have to integrate, which is minus cos x, and next integration will be minus sin x. Now using this in the formula, outside we have 1 by pi. Now u v1, u is x, v1 is minus cos x minus u dash, which is 1, and v2, which is minus sin x. So I can make this as plus into sin x, and next term is 0, and we have limit 0 to 2 pi. Using this limit, cos 2 pi is 1, and there is a minus sign and there is an x. For x, if I put 2 pi, and we can use a minus sign here, and sin 2 pi is 0. When I put the lower limit, first part is 0, second part is also 0. So totally this is minus 2. Now coming to an, the formula is 1 by pi integral 0 to 2 pi f of x into cos nx dx. Now this is 1 by pi integral 0 to 2 pi x sin x into cos nx dx. So we are going to use a trigonometric formula, writing this product as the sum of the terms. So the formula is, when you have cos x into sin y, this is half sine of, you have to add both the angles, minus sine of, you have to subtract both the angles. So we are going to take this term as a first term and this term as a second term. So when I have cos nx into sin x, this becomes half sine of, when I add nx plus x, it will become n plus 1x. When I subtract, it becomes n minus 1x. I have taken the x common in both. So substituting this, we have 1 by pi integral 0 to 2 pi x into 1 by 2 sin n plus 1x minus sin n minus 1x dx. So now we shall take this 1 by 2 outside. So we have 1 by 2 pi integral 0 to 2 pi. We have x, and the rest of the terms are written as it is. Once again, we are going to use Bernoulli's formula for integrating this. So, as usual, algebraic term is taken as u, this entire term is v. Now, u dash becomes 1 and u double dash becomes 0. Here, v1, we have to integrate this, which is minus cos of n plus 1x by n plus 1. Again, this is minus, but already there is a minus sign, so we can make this as plus cos of n minus 1x by n minus 1. Again, v2, this integration will be minus sine of n plus 1x by n plus 1 whole square, and this is plus sine of n minus 1x by n minus 1 whole square. Now coming to the formula, we have to take 1 by 2 pi as it is. Now it is u into v1. So u is x, v1 is this whole term minus cos of n plus 1x by n plus 1 plus cos of n minus 1x by n minus 1 u v1, then minus u dash, which is 1, into v2 minus sine n plus 1x by n plus 1 whole square plus sine n minus 1x by n minus 1 whole square, and we have 0 to 2 pi. Now substituting this upper limit, this becomes 2 pi cos of n plus 1 into 2 pi is always 1. So minus 1 by n plus 1, and again this is plus 1 by n minus 1. And sine of 2 pi x, 2 pi, n plus 1 into 2 pi or n minus 1 into 2 pi is always 0. Coming to the lower limit, since this has x, everything is 0, and these are sine terms, so everything is 0. So we left with only this much, and we can cancel this. Now we take LCM, which is n plus 1 into n minus 1. So this is minus n plus 1 plus n plus 1. So it is possible to cancel this. So finally we left with 2 by n square minus 1. This is our an. This is a plus b into a minus b. So a square minus b square, which is n square minus 1. And here n value is definitely not equal to 1, because when n is 1, this becomes not defined because denominator becomes 0. So in this case, I have to find a1 separately. For finding a1, it is again 1 by pi integral 0 to 2 pi f of x into cos nx, but n is 1, so cos x dx. So this is 1 by pi integral 0 to 2 pi x sin x into cos x dx. And we have a formula for sin 2x, which is 2 sin x cos x. So taking this 2 down, we get sin x into cos x as sin 2x by 2. So I'm going to apply that here. So our term becomes 1 by pi integral 0 to 2 pi x as it is. This is 1 by 2 into sin 2x dx. Again, as usual, we can take 1 by 2 pi outside, that is 1 by 2 is taken outside. Integral 0 to 2 pi x into sin 2x dx. So this is u, this is v, and u dash is 1, u double dash is 0, v1 is minus cos 2x by 2, v2 is minus sin 2x by 4. Again, using the Bernoulli's formula, we are going to get a1, which is 1 by 2 pi uv1 x into minus cos 2x by 2 minus u dash into v2, and the rest of the terms are 0. Now, using the limit 0 to 2 pi, when I put upper limit, this is 2 pi, cos 4 pi is 1, and there is a minus sign, so minus 1 by 2, sine term is 0, and when I put the lower limit, there is x, so this is 0, sine term is always 0, so totally it is 0. So we can cancel this. So the left out term is only minus 1 by 2. Now in the same way, we are going to calculate for Bn, which is 1 by pi integral 0 to 2 pi f of x into sine nx dx. So here this is 1 by pi integral 0 to 2 pi x into sine x into sine nx dx. Now again we are going to use a trigonometric formula for this. When I have sine x into sine y, this is, both are sine, so minus 1 by 2 cos of, we have to add both, minus we have to subtract both the angle. So when I apply that, so this we have to take it in the reverse order, sine nx into sine x. So this becomes minus half, and when I add, we get nx plus x. By taking x common, it is n plus 1x minus, on subtraction it is n minus 1x. Now coming to the integration term, Bn 1 by pi integral 0 to 2 pi x into minus half, so minus 1 by 2 into cos n plus 1x minus cos n minus 1x dx. Now again, as usual, this 1 by 2 along with the minus sign is taken outside, so minus 1 by 2 pi integral 0 to 2 pi is our limit, and we have x into cos n plus 1x minus cos n minus 1x dx, and this is u, and this entire term is v. We have to find u dash, which is 1, u double dash, which is 0. v1 is sine n plus 1x by n plus 1 minus sine n minus 1x by n minus 1, and next integration is minus cos n plus 1x by n plus 1 whole square, and again plus cos, because already there is a minus sign, n minus 1x by n minus 1 whole square. Now using the Bernoulli's formula, outside there is 1 by minus 1 by 2 pi, bracket open, u into v1, so bracket open, copy the v1 terms as it is, then next term is minus u dash into v2, so we have to copy this v2, which is minus cos n plus 1 into x by n plus 1 and plus cos n minus 1 by, sorry, this is whole square, and n minus 1 whole square. then whole bracket close, and we have a limit 0 to 2 pi. When we substitute the limit, sign terms are there. When I put 2 pi, it is 0. And since there is a x here, when I put the lower limit 0, the entire term is 0. So, substituting this, first term is fully 0. Here, when I put 2 pi, minus of cos n plus 1 2 pi is it's 1. There is a minus sign, so minus 1 by n plus 1 whole square. In the same way, this is 1 by n minus 1 whole square. There is an x term here. N minus 1 into 2 times 2 pi. So it is 1. So we completed the upper limit. And coming to the lower limit, first term is fully 0 because of this x. And open bracket, first term is 0, then minus, bracket open. When I put 0, it is 1, but there is a minus sign. So we take this. Again, this is 1 by n minus 1 whole square. So we completed the limit substitutions. On further simplification of this, we have minus 1 by 2 pi. This minus, if we take inside, it is 1 by n plus 1 whole square minus 1 by n minus 1 whole square. Again, this minus and this minus gets cancelled. So we have minus 1 by n plus 1 whole square plus 1 by n minus 1 whole square. So we see here, this is positive and negative term gets cancelled. Again, this positive and negative term gets cancelled. Totally, Bn is 0. But since we found a1 separately, we have to find b1 also separately using this integration. So 1 by pi integral 0 to 2 pi f of x into sin nx, but n is 1, so it is sin x dx. So coming to this is 1 by pi integral 0 to 2 pi f of x is x into sin x, again one more sin x dx. So it is sin square x. So 1 by pi integral 0 to 2 pi x into sin square x dx. We have a trigonometric formula for sin square x, which we have to use it here for integration. That is 1 minus cos 2x whole divided by 2. This is the formula. 1 minus cos 2x by 2. Now taking this 2 as usual outside the integration, we have 1 by 2 pi integral 0 to pi x into 1 minus cos 2x dx. This is u, this is v, and u dash is 1, u double dash is 0. v1, this integration is x into minus sin 2x by 2, and v2, this is x square by 2 plus cos 2x by 2, already there is a 2, so it is 4. Now using the Bernoulli's formula, 1 by 2 pi u v1, which is x minus sin 2x by 2 minus u dash v2, which is x square by 2 plus cos 2x by 4. So we substituted u v1 minus u dash v2, and we have to put the limit 0 to 2 pi. When we use the upper limit, this is 2 pi into 2 pi, sin term is 0 minus 2 pi whole square by 2, and cos term becomes 1, so it is 1 by 4. When I put lower limit, first term is x, so it is 0. Second term, first term is x square by 2, that is 0, and this is 1 by 4. So finally, we have 1 by 2 pi. This is 4 pi square. This is minus 4 pi square by 2. And we have 1 by 4. Again, there is a minus sign. So we have to take it as a minus directly without the bracket, and this is plus 1 by 4. So we can cancel these two, and after subtraction we get 1 by 2 pi into 2 pi square. 2 gets cancelled, pi and square gets cancelled, remaining is pi. Now substituting everything in our formula, f of x equal to a naught by 2. What is a naught we got, which was minus 2. So a naught by 2, which is minus 2 by 2, plus a1 we have to write separately. a1 we got it as minus 1 by 2. So minus 1 by 2 plus b1 also we have to write it separately. So which is pi. Then plus sigma. Now since we wrote the first term, now n is from 2 to infinity, and an, which we got it as 2 by n square minus 1. So here it is 2 by n square minus 1 into cos nx. In the same way, sigma n equal to 2 to infinity, the value of bn, which we got it as 0. So anyway, this entire term is not there, into sin nx. Now again, rearranging this is minus 1. So f of x equal to minus 1 by 2 is minus 3 by 2 plus pi plus sigma n equal to 2 to infinity 2 by n square minus 1 into cos nx. Actually, there is a small correction. Here into cos x will come, and here into sin x will come, because we put cos nx and sin nx. Since it is a1 and b1, n is 1. So we cannot add this here. We have to take it separately. The first term is minus 1 and second term is minus 1 by 2 cos x and pi into sin x. Thus we got the Fourier expansion for the given term. Now we have to deduce a term. For that, I am going to take x is equal to pi by 2. So when x is equal to pi by 2, let's find x, f of x, which is x into sin x. So what happens is, this is pi by 2 and sin pi by 2 becomes 1. So this is pi by 2 equal to minus 1 minus 1 by 2 into cos pi by 2 is 0, and again sin pi by 2 is 1, and here sigma n equal to 2 to infinity 2 by n square minus 1 into cos n times of pi by 2. Now we shall take this minus 1 and pi to the other side. So pi by 2 minus pi minus 1 goes to the other side as plus 1 equal to, we have this expansion starts from 2. So I am going to substitute 2 for n. So that becomes, but actually before doing that, in our question we have product of two terms. So it is better to rewrite this. That is, we keep sigma n equal to 2 to infinity 2 by, this is using a plus b into a minus b, n minus 1 into n plus 1. Then we have cos n pi by 2. So now this becomes minus pi by 2 plus 1. Now substituting 2, we get 2 by, this is 2 minus 1, which is 1, this is 2 plus 1, which is 3, and we have cos, when I put 2 here, 2 gets cancelled, cos pi, then plus 2 by, I have to put 3, so 3 minus 1 is 2, 3 plus 1 is 4, then cos 3 pi by 2. In the same way, it is 2 by, I have to put 4, 4 minus 1 is 3, 4 plus 1 is 5, then cos 5 pi by 2. Then if I put 6, it will become 3 pi, and 6 minus, sorry, here I have to put 4. This is actually 4. Now this is 5 pi by 2. So when I put 5, 5 minus 1, which is 4, 5 plus 1, which is 6. Again 2 into cos 6 pi by 2, which is 3 pi by 6 minus 1, 5, 6 plus 1, 7. So like this, it is keep going. Now finally this is, by taking LCM, minus pi plus 2. Cos pi is minus 1, so minus 2 by 1 into 3. Cos 3 pi by 2 is 0. Odd multiples of cos 90 are 0. So alternate terms becomes 0, and this becomes plus 2 by 3 into 5. Cos 2 pi is 1. Again this is 0, and we have cos 3 pi, which is minus 1. So minus 2 by 5 into 7. Like this, it's keep going. Now I'm going to change the sign throughout. So this becomes pi minus 2 by 2 equal to 2 by 1 into 3 minus 2 by 3 into 5 plus 2 by 5 into 7 minus dot dot dot. Now taking 2 common here, this is 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot dot dot. It keeps going till infinity. And this 2 which is taken here will be multiplied to the denominator. So pi minus 2 by 4 will be 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot 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 till infinity. Let's check the question. 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 dot minus dot dot infinity is pi minus 2 by 4, which we got it here. Just to rewrite this. So 1 by 1 into 3 minus 1 by 3 into 5 plus 1 by 5 into 7 minus dot 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 till infinity is pi minus 2 by 4. Thus we deduce the given expression in the question.